Hello everyone, welcome back to my channel Info Lab, and it's another day of Advent of Cyber 2024 from TryHackMe. In today's room, we're going to do some game hacking, which is not a very popular topic in cybersecurity projects that we do. So the learning objective is to understand how to interact with an executable API, intercept and modify internal API using Fritter or Fritter, hacking a game with the help of Fritter. So before we get into the activities of the room, then as usual, we're going to go over some concepts, executables and libraries. So what is executable? Executable file of an application is generally understood as a standalone binary file containing the compiled code we want to run. While some applications contain all the code they need to run in their executables, many applications usually rely on external code in library files with the S or extension. So executable files are just like those files on your Windows machines where you or Mac machines where you just double click the icon of the applications and the application runs. Those are executable files. And then libraries are collections of functions that many applications can use. Unlike applications, they can't be directly executed as they serve no purpose by themselves. For a library function to be run, an executable will need to call it. The main idea behind libraries is to pack commonly used functions so developers don't need to re-implement them for every new applications they develop. So let's say math functions, for example, if you want to add two numbers, subtract two numbers, multiply or divide two numbers, you can have those functions across different applications like calculators, banking app, or financial tracking apps. Those apps all use the same arithmetic operations: addition, subtraction, multiplications, and divisions. So instead of writing different functions in each of the application, it's a little bit inconvenient. So that's why we have a library where these apps can refer to when they are executed. Those are the benefits of using libraries for the apps. Okay, so hacking with Fritter or Fritter. Fritter is a powerful instrumentation tool that allows us to analyze, modify, and interact with running applications. How does it do that? So basically, Fritter is like Burp Suite in web applications. You run it, it will act as a proxy between the executable file and the library files, the functions in the library file. Whatever you do with applications, it will be outputted onto the screen when you run it. And eventually, if you have enough logging system or if you have enough messages to print out on the system, you can actually debug and know what actually running behind the scenes of the applications. To be clear, now it may sound a little bit confusing, but let's dive into the example and see how it actually works. Okay, we're on the terminal right now and we have a folder called, let's go to desktop, and then on desktop we have the TryHackMe, which is the name of the game. So we go in there and we have, let's see, we have the executable file TryHackMe. Let's try running the game. Press space, continue, move. Okay. So as you can see right now, we're running the game, but whatever action we do right here in the game, it doesn't output anything. So it's kind of hard to know what actually going on behind the scene. That's where Fritter or Fritter comes into play. To run it, first we're gonna be running this command. Well, as it's stated right here, we will run the Fritter trace for the first time so that it creates handler for each library function used by the game. But right now, since TryHackMe has already provided us with the handlers folders and the assets folders, so inside these handler folders, it contains all the functions necessary to run this TryHackMe games. So we don't have to do anything in that. We can now to actually track the applications to see what's going on between the application's executable file and the library functions, we can actually run Fritter trace right here, this command. This is the name of the application. In this case, it's TryHackMe, and then here is the name of the library. Right here, this is the library that contains all the functions to run the TryHackMe apps. Free trace and then TryHackMe -i, and then we're gonna be running live AoC game.so. Okay, so press continue. Okay, let me minimize the windows a little bit so it's easy to keep track of everything. So on top is terminal, and then here at the bottom is the game that we play. So whatever we do in the game that performs a function, it's gonna be output onto the screen right here. See, it seems like a function OTPI is called. Now, for now, let's just ignore that. We don't know what it is, but we'll get to that later. Alright, welcome to an iGame. Aren't smart lock good enough? Okay. And now we're about to enter the OTP and press enter, but we don't know what the code is, so it's likely that it's impossible for us to move forward. However, on the terminal right here, it shows that this function is called, meaning that we should go to this function and take a look at it. Now open a new terminal, and then we go to handlers. Inside handler is the library of the function. Is the library, so go into the library, and then we see right here there are 4 JavaScript functions for the application. So we're gonna be inspect each of those and see what we can exploit from these functions. In order to do that, we're gonna be open these functions in Visual Studio, which will run code dot. Now this command will open the Visual Studio's Visual Code editor, where it contains all the JavaScript. Alright, let's go back to the original screen terminal right here. So when we interact with the character within the game, this function is called, and then we actually can see it right here. Set OTPI. Now to give you a little bit of explanations of the naming convention, you see set OTP, meaning that it's setting the one-time password, and then the I here indicates that it takes one integer as one argument for the function, which it shows right here. Alright, so what we can do is it's always best practice is to lock all the content or whatever we're interested in. So let's take a look at what actually printed out from this function. So let's use the log function, and let's see. TR group one is save it, and then we try one more time. Okay, so this looks like a hex value. Let's try cyber chef and then run it. Form hex Nothing. Okay, let's get back to the instruction, see what it does. Oh, we have to use this function 2 in 32. Okay, let's try that. So arguments is right here, and then convert that 2 in 32-bit. Save it. Now let's try one more time. Let's see if we get different values from the output. This is the visual code. Oh, right here. So this got to be the argument, the OTP, the one-time password code. So 356,525. 356,525. Ding ding ding, welcome back my malware. You may now proceed. Alright, so this is the first flag. Okay, let me write down the first flag. TryHackMe one tough password is the flag. Okay, let's move on. Let's move on to the game. Okay, the same concept. This is stage number 2. We see another penguin. Let's talk with the penguins. Second authentication factor is called a wish list for billionaires. Okay, sounds shaded. How does it even work? At least you are more security aware than the last guy. Okay, am I? Alright. I'll explain just once, and cause you like it, my way is the only one in Waveville with a super ultra mega premium extra hyper plus card blend. This means he's the only one who could buy the covered flag 2 item from the store. So he was the only one who can buy it. He does, but then refers the products. Should be rich by now, if not the chip maker. Okay. But hey, if you are having cash issues, you can always mine some coins from that OPC. Is there anything you want to buy now? Advice $5, coin $10. Okay. Okay, so let's go to the PC. 1, 2, 3, 4, 4, 5. Okay, let's go back, see what it does. Let's try to get an advice. A narrow focus brings result, but something. That's not very helpful. Okay, so we see on this terminal the output is purchase I. So this is gonna be the next function we look at. As I explained earlier, from this function, because there was one I, it only intended one argument, whereas this one, it contains 3 I's, meaning that there are gonna be 3 different arguments for this function. And because of that, again, we're gonna be locked to see the values of these functions, to see the values of this argument. Sorry. Meter 1 plus 0. Okay. 2, 3. 1, 2. Control S. Oh, remember to save the changes every time you make every time you make a change to the file. Save those changes so it reflects into the game. Is there anything you want to buy? All right, let's see. Let's try number 3. checking your credit card. You don't have enough money, use pieces to get more coins. Okay, but here we can see the parameters value right here. Again, we can try to convert to integers. Dot 2 in 32. Copy this one, paste, save the changes. Retry one more time. 3. As expected, we're not allowed to buy the flag. But here, hey, take a look at this. Parameter, it seems like the first argument is going to be the item's ID. Second is going to be the price of that item. And then the third one is supposed to be the coin that we have. Let's double check one more time. 1, 2. Yeah, let's make it 1. Should be fine. So ID is 3. Value is 1 million coins. Yep. So the first argument or parameter is going to be the item's ID. Second value is going to be the item's price. And the last one is our budget, which is 1 in this case. Now since we already figured out what these parameters are, it's kind of easy to actually manipulate the data. We can actually set the arguments right here. There are 2 ways. Alright, so in order to hack the game, there are two ways. You can either make the price to, you can either modify the price of the item equals to whatever you have in your wallet, or you can just like make yourself a very rich person by adding 1 million coins and then from there buying the items. Either way, doesn't matter. Let's try. I want to be rich, so let's try giving me 1 million coins. So the last one is gonna be number 2 is also equals No. 1 million. Let's try one more time. Is there anything you want to buy? Number 3, 1 million coins. Yup, we are rich. Checking your credit card. Welcome back, my way. You may now proceed. Alright. TryHackMe. Flag number 2 is credit card undeclined. Thank you. Let's move on to the next stage. Hey, another penguin. Just one more factor to overcome to fully become malware. Okay, the last authentication factor is biometrics. At last, a normal authentication factor. So whose eyes do I need? Eyes. This is a punch-based authentication system. malware has a very specific way of punching the keyboard that nobody can replicate. And here we go again with the madness. Should I punch my keyboard in? Well, you can gently put your hand on the keyboard. No need to get violent. I was worried for a second. Now show me the keyboard. Please input your fist in the keyboard. Bum 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 bum. Naughty fingers, I see. Are you sure you are malware? Nope, I'm not sure. Okay, so we have biometrics PK. See, what do we have? All right, what the C is, so it's taking one argument as characters. So log again we're gonna be doing the same thing, parameters, and then plus R. Same thing. Not the fingers I see. Are you sure you're my malware? Not for now. Okay, so since the argument is not integer, we can't really convert that to integer types. It's a string of characters, and let's see what function they use. Okay, so this is the function used. Let's try that. Okay, so this looks like the values of the argument that input into the function. Now you may wonder, what do we do with this one? I'm not sure. Like, there's nowhere else we can do with this one. We can try actually look into this one and see what happens, but there's nothing we can do. I mean, the application doesn't even call this function, keycard pk. There's no way it was found on the terminal, meaning that this function, for some reason, it was untouched for this application. So right now, let's just focus on this one. This one, there's nothing. And since, even though we get to see the argument, the parameters of the functions, we can't really do anything with this kind of this value. So let's try to see what it returns. In this case, we can try to bring out some output, returning values. Let's see, reval. We can also see the state, returning state plus state. Let's try one more time. Returning value is 0, 0. Okay, object. So as we can see, the return values is 0. It looks like a boolean values 0, 0. Well, obviously because we were rejected, so the value should be false, which is 0 right here. So right now we can try to modify this value to be 1 and see how it goes. Let's try that. Red val equals 1. But hold on, how do we do that? It's not integer, it's a hex. Okay, the following instruction will set the return value to true. Okay. Return value replace and let's see one more time. Now keep in mind that if this works correctly, then we should be able to get a flag. Oh, alright, different messages. Looks like it works. Mayama would have hit it with all his might. Who are you, imposter? You can't fool me. Me, I'm the mayor. Yes, mayor, will vote for me, please. Oh, my bad. Welcome back, mayor. We've missed you. Here's the final flag. Don't smash your keyboard. Don't smash your keyboard. Alright, so we have successfully cracked the game. Let's try answering the question. What is the OTP flag? OTP flag is one tough password. If you recall, second flag is credit card undeclined, and the last one, biometrics. Don't smash the keyboard. If you like today's task, you can practice your skill with Memories of Christmas Past Advent 2023, okay? Second penguin gave a pretty solid advice. What was it? Oh no, we have to go back and reflect. You know what? Just ignore that. So, in summary, this is how you crack a game using Frida or Frida, whatever you call it. So basically, the concept is you intercept the function calls between the application, in this case, the game TryHackMe, and then the libraries where it contains, and the library that contains all the function calls for this application to run. So Frida is like Burp Suite in web applications. It allows you to intercept the traffic between those two, between the applications and the libraries. And everything is just like the same. You try to log as many informations as possible, and then try to modify the data so the applications or the game in this case flows in unexpected function in unexpected way. Now, in terms of the functions, these are all JavaScript functions, and if you're not very familiar with this, don't worry about that. The main point is to get the concept how to crack a game, not how to dive deep into understanding the syntax and what these function calls are or what R's and state mean. And it's kind of out of scope, even though if you're actually interested in this kind of code, JavaScript, then you're free to do it. But don't worry about these functions. Like, you may ask, how do we know when to use memory read string arguments, or when to use the return value dot replace, and what PTR means? Don't worry about it for now. These are all just like accessories from TryHackMe that helps you complete the task in the room. Alright, but still, if you're interested in those functions, feel free to let me know. I'll be happy to explain to you. Thank you very much, and I'll see you next time. Bye.